Hello, we're going to be talking today about molecular representations. So when you were in general chemistry, you learned about molecular formulas, and this is a molecular formula that says only an inventory of the atoms. So 3 carbon atoms, 8 hydrogen. But it doesn't say anything about how they are connected. So then you learn it about Lewis structures. And here in the Lewis structure, you see each of the carbon atoms has 4 bonds. And now I have all my 8 hydrogens. So that is the Lewis structure. And as I said, gives you information about connectivity, how the atoms are connected. Yet I don't know anything about the shape of the molecule. So I remember that in the methane is the carbon, the central carbon is sp3 hybridized. So here I have the symbols that we use is we have this dashed line to represent something that is away from my view, so pointing in. And then I have the wedge, and this is showing me something that is, say, going towards me, toward the viewer. And these 2 bonds are in the plane. So this is a tetrahedral, running out of space, tetrahedral geometry, right there. So that is a shape. This is the alien shell electron pair repulsion. That's a shape. And I can do this kind of drawing here. And I remember that each of the carbons is sp3 hybridized. I'm going to do that again here. So I have this bond to the carbon. And then each of the carbon has 4 bonds. So the carbon in the corner will have this bond. They might need to have, see, as we have in methane, 2 bonds on the plane, 1 in, 1 going out. So 2 bonds in the plane, 1 is going in, this is sticking out. Here, the central carbon, 2 bonds in the plane, 1 is in, and the other is going out. And same for the other carbon. So 1 hydrogen, another hydrogen, and so in, out. So that again is propane, but now this is 3D. I know these are tetrahedral structures around each of the carbon. Now, there's yet another type of representation. What thing I can do is, I'm going to say now, I'm going to write the 3 hydrogens attached to the carbon together. And then I'm going to have this 3 also together. And then this 2 attached to the central carbon. In my next drawing, them is going to be, this 3 is going to be CH3. Then this 2, CH2. And then this 3, CH3. See? Now, this is a condensed molecular formula. Now, everything is like more complex, right? Yet there is more, we can do more than that. Now, what we're doing now is learning how to do line structures. And here I am going to erase this one, but we're going to keep that in mind. So I'm going to erase the 3D to show you how to do the line structure. Just for this one example. So 1, 2, 3. So in line structures, we're going to only draw the lines connecting carbons. We're not going to draw the carbons explicitly and not the hydrogens connected to carbon. So we're not going to draw a C. We're not going to draw an H connected to a C. To a C. So we're not going to draw that. So we're drawing one line here to represent this line and another line to represent the other one. And that's it. That is the line structure for propane. Okay? So we're going to do more of that in our next video.